Let's look at another example of the computation of a limit at infinity, where we have rational functions. So suppose we were asked to find the limit of 3x squared plus 1 over 5x cubed minus 2x plus 9 as x approaches, or as x goes to minus infinity. Here we know, as we just learned, we can simply apply the theorem, or we can look at the leading coefficients, factor out the leading order terms on top and the bottom, and then simplify whatever we can and do that. But since we've already done that on the end of the previous video, we'll just apply the theorem, which tells us that, and just asks us to identify the leading order terms. So here in this case, n is equal to 2, that's the degree of the numerator, and m is equal to 3, which is the degree of the denominator. And what matters is an, which is 3, and bm, which is 5. Okay, so this limit they were trying to compute is then going to be equal to 3 over 5 times the limit as x approaches minus infinity of x to the n, which is 2, minus m, which is 3. This is equal to 3 over 5 times the limit as x approaches minus infinity of x to the minus 1. And if we look at the theorem for powers, the limits of powers at infinity, we'll learn this is equal to 0. And this is natural because we're computing the limit of 1 over something very negative but very large, so that you're coming closer and closer to 0. So we get 3 over 5 times 0, which is 0. Okay, so that is the so that basically sums it up as far as rational expressions go. But we'll see some adaptations. Method 2 non integer exponents and algebraic functions. So we'll just look at a couple of these. First one is that you compute the limit as x approaches infinity of 2 times x to the 9 over 2 minus 3 x to the minus 1 half divided by x squared plus x to the 1 half. Again, we notice that this is an indeterminate form. This is infinity over infinity. The leading order term on the top is x to the 9 over 2, and the bottom is x squared. So what we do is to write this as the limit when x goes to infinity of x squared to x to the 5 over 2 minus 3x to the minus 5 over 2. All of that divided by x squared, 1 plus x to the minus 3 halves. We just look at, I simply took out a factor of x squared in the top and the bottom. If we were to distribute this, we would get 2 to the x 5 over 2 plus 2 minus 3x to the minus 5 over 2 plus 2. Right, and this thing here is x to the 9 over 2, and this other term here is x to the minus 1 over 2. Get 4 minus 5 over 2, which is x to the minus 1 over 2. We can see the same thing here with the denominator. So x squared times 1 is just x squared, and that plus x to the 2 minus 3 over 2. Okay, and this is 4 minus 3 over 2, which is x to the 1 half. Okay. X to the 1 half. This is just a factorization by x squared. Okay. And then we can simplify and get rid of the x squared. And we get that this is the limit when x goes to infinity of 2 times x to the 5 over 2 minus 3x to the minus 5 over 2 divided by 1 plus x to the minus 3 over 2. Now, this is just 1, so this is going to 1. We're sending x to infinity, so x to the minus 3 over 2 is going to 0. The same, we can say the same about 3 to x to the minus 5 over 2. It's going to 0. We're erasing x to the negative power. And so the only term remaining here is this one. So this is just 2 times the limit as x approaches infinity, gives us the 2 times the limit when x approaches infinity of x to the 5 over 2. But since 5 over 2 is positive and we're sending x to infinity, this just gives us infinity. 2 is positive, so this whole thing is, the limit here is plus infinity. And that's it. Okay, so if instead we had arrived at an exponent and a negative exponent, then this limit would be equal to 0. This coefficient here is important also because if instead of having 2 times x to the 5 over 2 we had minus 2, then this limit would have become minus infinity. Okay, so pay attention to the sign of the leading coefficients. Another example, this one involves square roots. So limit of 4x minus 3 over 25x squared plus 4x. And so what is this limit equal to? This is equal to the limit as x goes to infinity of, and here we factor out of 4, so we take out a factor of 4 of x, minus 3 over x, and the bottom we have something on the square root, so we can factor out as x squared and x squared, 25, then plus 4 over x. If we bring x squared here, we get x squared times 4 over x, which is 4x, so this is alright. And then this is equal to the limit when x approaches plus infinity of x times 4 minus 3 over x, all that divided by the square root of x squared times the square root of 25 plus 4 over x. And since x is positive, this is just x, so this is just equal to the limit as x approaches plus infinity of x times 4 minus 3 over x divided by x times the square root of 25 plus 4 over x. We may cancel the x's here, and this goes to 0, this goes to 0 as well, and we get then 4 over the square root of 25, which is 5, so that will be our answer. Okay, so that's the other example I wanted to go over with you. And I also wanted to warn you about something you also need to pay attention to here. What if instead of taking the limit as x approach plus infinity, we take the limit when x goes to minus infinity instead. Well, there's one thing that would change here. So then the limit will be equal to the limit as x approaches minus infinity now. We'll still take a factor of x, 4, then minus 3 over x, minus 3 over x, and then we'll divide that by the square root of x squared again, times the square root of 25 plus 4 over x. And here's the difference. If you take the square root of x squared and x is negative, this would not be equal to x now, but instead minus x. If you think about it, if you take the square root, what is the square root of minus 5 squared? Is the square root of 25, which is 5. Okay, so and this is equal to minus 5. So you need to multiply that by minus. So in general, the square root of x squared is just the absolute value of x. So that's what this conversation is about. So you basically need to take the limit when x approaches minus infinity of x over the absolute value of x times 4 minus 3 over x divided by the square root of 25 plus 4 over x. This still goes to 0. This still goes to 0. So this whole thing goes to 4 over 5. But this depends on whether you're going to plus or minus infinity. If you're going to plus infinity, the absolute value of x is just x. If you're going to minus infinity, it's equal to minus x, so you get a negative sign. So in this case, we get minus 4 over 5 instead of 4 over 5, which is what we got before. And so you need to pay attention, especially when taking square roots, whether the limit is at plus or minus infinity. Because whenever you have square root of x squared, this is a very important thing to remember, that's equal to not x, but the absolute value of x. Okay? So here, this is exactly what we wrote over here. Okay, so hopefully you keep that in mind in the future. This concludes the section 2.7, and it's also the end of the module.